So number 6 from the worksheet. So to calculate the PI of the cysteine. So first, what is the definition of PI? So PI means that PI is actually the pH at which the structure has zero net charge, right? So it means that that structure will give you the neutral net charge. So to calculate the PI of cysteine, you have to know the structure of cysteine and determine which form of cysteine has zero net charge. Cysteine has 3 different pKa. So the first pKa of histidine is the pKa of the alpha carboxylic group. So I got this value from the appendix at the ends of the SIGO book here. So the first pKa is 1.71 here. And then the second pKa is 8.33, which is the pKa of the SH group at the side chain. And the last pKa is 10.78 from the alpha amino group. So you have to get the charge on the structure right. So the first one, because 1.71 is the pKa of carboxylic group here, so it will be the first one to deprotonate. And then the second pKa is from the SH group, so the SH group is deprotonate at the second step. And then the last step is the proton from the alpha amino group that is deprotonate. Okay, so now we got the whole structure, the 4 different forms of cysteine here. So right now we have to figure out which one of these structure give you the zero net charge. So for the first form here, you will get +1 charge, right? And while the second form, you get a neutral charge. And the third form, you get -1 charge. And then the last form, you get -2 charge. Sorry, yeah, -2 charge here. So you see that right now, the second structure give you a zero net charge. So to calculate the PI of this structure, that's one equation that you can use here. So PI will be the average of 2 pKa. So pKa1 plus pKa2 divided by 2. So which pKa you should plug into this equation? So it's actually the pKa that cover the structure. So if the structure is fall in the middle of the 2 pKa here, so you use the pKa 1.71 plus 8.33 divided by 2. And this is the value of the PI for cysteine.